Alright, it is stream time. Welcome to the thing where I stream about a project. In this case, I'm continuing on with this kind of weird Rust project. It's a sort of a work in progress sandboxing library. It's designed to make it secure and convenient to run these super low privilege containers inside your application for doing things like multimedia transcodes. Sort of a piece that I decided I needed for a larger decentralized video project. Well, welcome back to the stream. I'm gonna make sure we're all broadcasting in the right places, but the most important thing is to check out the cat cam here. Looks like we are live on YouTube on the Scanlime-in-progress channel, as well as Twitch, twitch.tv/scanlime. Those are the two chat platforms I've been using these days. I've experimented with some separate platforms, but I currently don't have any of those in the rotation over here at the moment. You can also get the bits directly from the source at that other address, live.diode.zone/scanlime, which is kind of fun. And we are online, and the cat is in permocouple mode. He keeps insisting that I open the back door because he likes the view, and I think he likes the cold air. But then he gets tired of the cold air and he rushes back to his little heated pad over there. So that's kind of his thing these days. I'm learning how he behaves in all of the different seasons, because it's kind of nice to live somewhere that has seasons again. I used to live in the Bay Area where it was pretty mild all year round, and here it's a little bit colder in the winter and quite a bit warmer in the summer. My old place was pretty drafty, and it's less drafty here, although I certainly need to work on the insulation, especially this door I'm sitting right next to. Tuco's so good. I'm going to try to keep a view of him as we work on other stuff. So this is the project that I've been hacking on recently. Oh, is he coming back over here? Oh, he's just leaving. How rude. Right after I tell you folks I'm going to keep him on screen, he's forcing me to break my promises. Well, I'll try to keep an eye on that for when he returns, but at the moment I'll hide this to save screen space. Alright, so this is called Bandsocks because I just needed a silly name for it, and I like the idea of a bunch of socks playing instruments and emulating system calls. Architecturally, it's probably most similar to something like user mode Linux or gvisor, in that it's sort of trying to be a layered kernel that you run inside of your real kernel, implemented in user space using no special privileges. But in this case, unlike something like user mode Linux or gvisor, both of those are quite complete kernel implementations. They aim to do everything in emulation, whereas with Bandsocks, my goal is to keep the I/O paths fairly clear of obstruction, so things like read and write will be able to just map directly through to the real host kernel, so that I hope to interpose very little for things like video transcoding and like I/O workloads. So if you're doing video transcoding, the kernel is mostly staying out of the way anyway. You're mostly running user space code, which is doing work on the CPU, maybe the GPU even, and it's doing semi-high bandwidth I/O on the input and output. So there are going to be calls to read or write, maybe a map, but probably read or write that you want to kind of optimize for somewhat. But even then, like, the amount of work that you're doing on the CPU is, most of what's going on. The amount of time you spend on I/O is probably still pretty low compared to the amount of time you spend actually encoding video or decoding video. And all of that stuff is just running in user space, with seccomp acting as a layer protecting it from running system calls that you don't want it to run or that you want it to run via emulation. But, in that common case where it's just running like multi-threaded x264 code or whatever, that's just going to run pretty much as normal. We're kind of lucky that operations like mutexes in the common case normally don't require a system call, and most applications these days are going to be using fast user space mutexes or futexes, which require a system call only when they are contended, not in the kind of more common uncontended case. And I don't see any reason, I haven't audited this yet, but I don't see any reason why we can't pass through futexes to the host kernel. So that can also be an area where there's already fairly low overhead and we don't have to add any additional overhead for this sandbox implementation. So that's kind of the idea. It's designed to be a little bit like gvisor, a little bit like user mode Linux, but simpler and easier to deploy inside sort of existing applications in low privilege environments. So the idea is you can just link this with your Rust program. You don't need any runtime dependencies other than libSSL maybe. Currently it uses the system SSL on Linux because that's what people usually expect, but even that could be reconfigured. It has very little in the way of external dependencies. It just needs a Linux kernel, really. This is a very Linux-specific project, and at the moment it's pretty x86 64 specific, although it would be possible for sure to port this to other architectures, but it would require some porting work to make this work on ARM. Right now, there are a couple of modules that are just full of x86 64 specific details. We're relying on the specific set of system calls that exist. We're relying on, the way that they're encoded in registers, things like that. So it gets pretty low level in the architecture. This is not really usable yet. There are some tests that work, but it's really more of an interesting sort of emulation experiment at the moment. It's not something I would recommend people actually use, although I do hope to make it actually useful, because I want to be able to use it in my own projects. But I do have what's maybe a first pass at the public API for this library. So I don't consider this to be super stable yet, but I think it's also a pretty good representation of what I actually want this to look like. So it has fairly high-level objects for doing things like pulling images from a container registry or building a container or setting its parameters. But the simple way to interact with this looks a lot like creating just a standard command line subprocess in Rust, except you can start out with an image hash that identifies, in this case, a publicly available image in the default image registry in the default repository within that registry. So this actually expands to something like registry1.docker.io/library/busybox. But of course that's just a default, and you can override that. You can specify options for how the client should connect, what specific defaults it should use. You can, have allowed and disallowed servers. So I try to add enough knobs to kind of let you tune the kind of network client part of this to whatever kind of amount of kind of locked down setup versus sort of ease of use you want to hit in a particular application. By default, it tries to kind of just act like the Docker command line app. So it'll do things like pull from localhost over HTTP if you want, as long as you give it a hash to identify the image securely. But by default, it's going to be contacting a server over SSL and TLS and HTTPS, and the way I use this in all of my test cases is to refer to a specific image by hash. So you're also getting that verification. If anything is different in the manifest, then this hash wouldn't verify. And if anything was different in the individual images, then they wouldn't be identified from the manifest, since everything is content addressed. So this does give you kind of a succinct way of trusting a specific piece of content, even if you don't necessarily have, depending on how much you want to lock down the actual network pipe, you maybe don't need to lock down the network pipe very much if you are locking down the specific image hashes you accept. So there's some flexibility in how I want that to work. And then in my eventual use case where I want to use this for video encoding, I'm imagining that the server operator might have a whitelist of maybe specific encoding hashes or specific registries or repositories that they're allowed to get images from, but then also the specific image digest becomes part of the description of a video transcode object. So when you've transcoded a video and shared it, you're also sharing the information that's necessary for someone else to verify that transcode or recreate that transcode, so that can be part of the caching system. So then the other interesting part of this is this mount trait, which is kind of cool. This is not intended to be implemented from outside of this module because it relies on this internal type that I don't think I would want to include in the public API, this file system object. It's possible I decide to vastly expand the public API here, and maybe I want to make the file system a little bit more public, but right now I'm trying to consider that to be more of an implementation detail. And the idea is that I would expose various interfaces that have this mount trait, and then you could supply them as basically mount arguments for a container that you're building. So you would start by calling container new. Well, you could call container new if you already have an image. The image is wrapped inside one of these atomic reference count objects because the image in this state can actually be shared pretty efficiently between multiple containers. And there's some logic in there so that if nobody else is using the image, it can just take ownership over it. So if the reference count is 1, but it's also pretty cheap to just spawn a bunch of containers from the same image after you've loaded that image into memory. But you can also take a shortcut and give it a name and just pull the image from the network and start a container in one step. And so this gives you one of these builders, which you can use a bit like a command in the standard library. So there's a spawn and an output call. There's also interact, which is a bit like wait, except in this case, we never inherit standard I/O streams, both to kind of keep, I don't know, that's just an architectural call I made, that it seemed safer for the sandbox to never have a mode where you directly allow access to the same file object. I think I'm also disallowing most kinds of I/O controls and F controls, but it would be useful, for example, to reduce the attack surface of the host kernel that's available inside the sandbox to keep the sandbox from getting access to esoteric file handles like pseudo terminals and getting the ability to call F control on them. So yeah, my intent is to have fairly limited support for standard I/O interactions, since this is mostly for compute workloads you're running in the background. But for cases where you do want to interact with standard I/O, there's a method that uses basically an asynchronous lightweight task to shuttle data back and forth between the actual standard I/O sockets on this container and the Rust standard I/O objects, which are themselves somewhat weird. Rust has its own built-in standard I/O abstractions that wrap the regular standard I/O file handles, and they have some weird properties there's a single standard in reader that's shared by all the threads, and that standard in reader is always blocking, so we have to kind of special case that. So interact is not as straightforward as maybe it should be, and so it's kind of a useful building block to include in here, even though you could build it using these other pieces. You can attach what's effectively a wrapped reference counted socket directly to one of these standard out, standard in, standard air channels. My intent is for there to be several primitives that are these sort of different flavors of OS level file objects. So things like sockets or socket factories or in-memory file descriptors, MMFDs, that would be used for achieving different kinds of interaction with the container. And then there'd be objects like this shared stream that you could mount into the container to give you kind of a more user-friendly way of dealing with these. So yeah, the high-level entry point to attaching stuff is this mount method on the container builder. So you can just give it a path and some kind of object that knows how to modify the file system. So this could be as simple as just linking in a single socket, making a new inode for it. Or it could be maybe you want to mount something that looks like a read-only tar file or something. So this could do the equivalent of extracting that tar file's metadata into the sort of lightweight clone of the file system that that particular container has. And so then its mount might be a somewhat more involved operation. So yeah, if you're into this kind of stuff, I'd appreciate comments on the API, but otherwise it's mostly just there so the documentation exists somewhere at the moment. The actual thing I wanted to dive into here is mostly just debugging. I've been just trying to get some basic programs running, like BusyBox compiled with different libraries, maybe a dynamic linker, and I had a couple of somewhat messy work-in-progress refactors that I also kind of need to sort out that I just SCP'd over to this machine so I could deal with them on the stream. So I get to deal with that. Hopefully my cat comes back at some point, because I know he's the star of the show. So I think this tree is in a reasonable place where we have some test cases that work. I have some test cases now for both the muscle and UClibc builds of BusyBox. I didn't really get to the bottom of that crash inside of malloc that I was looking into in the last stream. I just kind of switched to debugging different problems. Like, a lot of these are going to be potentially like overlapping root causes, so maybe debugging a different problem gives me a different way to approach the same root cause. So yeah, I think then I tried to get UClibc working, because it seemed like it was pretty close to working. It was just failing in a way that was pretty easy to debug. It was just something wrong with the way I was calculating load addresses for fully static binaries, like not position-independent binaries. So I fixed that bug and cleaned up some of the load address calculation code. And now I can run some of the UClibc BusyBox programs. And hello to folks in chat. I'm trying to keep more of an interactive chat experience going on here. I did at least find a better place to mount the screen that has the chat on it, so it's not always so far away and awkward. All right, and then I was working on this computer and had a work-in-progress change. Okay, yes. I was trying to get an additional test case running. So there's this one that was commented out, Ubuntu LDSO. That might be kind of fun to demonstrate. I found a case where it was working only if I added like an unnecessary environment variable. So it seemed to be one of those things where, it worked if there was like an odd number of environment variables, but not an even number of environment variables. So like it's a stack alignment problem. And I think in the current code, I'm aligning the stack and then pushing a bunch of, so I'm pushing a bunch of like variable size stuff onto the stack, like strings, and then aligning the stack to a 16-byte boundary, which is where the application actually expects it to be aligned. But then I'm pushing a bunch of the arguments that main expects, like the environment variables and the argument lists and all that. But, it actually expects the 16-byte alignment after the arguments, not before the arguments. So I think I need to separately calculate some padding based on how many arguments are there. So I just need to fuss with that code to make it so that I can implement that somewhat cleanly. So yeah, I don't think. Yeah, sure. Let's just start with that. I think this tree is already good. Yeah, this is from last stream. We were deep inside the muscle source code. I was just trying to work through how relocations were supposed to be processed and whether they were broken. And it looks like the answer was relocations are processed by this kind of hacky way of compiling part of the dynamic linker into the application by like pound including this whole file and pound defining dl start c to start c. So, but I stepped through this in the instruction trace, and it seems like we're basically doing the right things. And I've not seen any clear evidence of the relocations being broken. I've just seen some kind of telltale signs of crashes that look like they're on unrelocated addresses, but those could be just something else that happens to look like the same kind of address. Oh, and then I was looking into thread local storage. I was getting a crash inside here, but I couldn't figure out if I was doing anything wrong or if that was just a coincidence. But I was looking closer at my elf loader, and there were definitely some things I was doing wrong. So there's the stack alignment thing that I definitely need to fix. There's also some subtlety in the way data segments are loaded. So, the usual way a program is linked, you have a read-write initialized data segment where the memory has read-write permissions and it's being initialized from a chunk of data that was just on disk in your ELF file. So the way that works is you just mmap that section of the ELF file into memory. But then there's another section of memory that's usually right after that is your uninitialized data segment, often called your BSS segment. I forget what BSS actually stands for. Yeah, it's probably something super archaic, but that's just what everyone calls the this sort of ELF standard zero initialized data segment. So, those could be separate entities, but the usual way that they're represented in an ELF binary is to have one load instruction in there. So like one. So ELF is very confusing. It's easy to get segments and sections mixed up. So usually, I think sections are always the linker sections, and segments are used by the kernel for loading. So in the program header, that's kind of what the kernel reads to instantiate a program, and it has a bunch of segments, which could be things that the dynamic linker ends up looking at later. But the sort of common type of segment is a load instruction that instructs the kernel to map some memory from disk. And there's this thing that at least Linux does. I don't know if this is like actually part of the ELF standard or if it's a Linuxism, but if you can have one load instruction that has a memory size that's larger than its disk size, and that actually instructs it to use the first part of that as a mapping from disk and the rest of it as zero initialized. But then that boundary doesn't actually have to be page aligned. So the thing that I'm doing right now converts that into two separate mmaps, one large anonymous mapping and then a smaller file mapping. But Linux actually does that, and then it also goes through and specifically zeroes out the non-page aligned portion in that load segment. So it's kind of ridiculous that programs depend on this kind of behavior from the kernel to load correctly, but this is where we are with computers. So I haven't actually traced any of these specific crashes back to that, but it's been on my radar as something that I know I'm doing wrong that seems very likely to produce some weird crashes like what I'm seeing. Catching up on chat a little bit here. Oh, great. We have a expansion here for BSS thanks to Walrus. It's block started by symbol. Oh, weird. Historically, BSS from block started by symbol is a pseudo operation in some aircraft assembly language from the 50s. Okay. So that was just the name of the assembly instruction that was used back in the day, and then it stuck as the name of the segment. Interesting. Yeah, so apparently there's a Wikipedia article on this which actually starts with dot, because that's the traditional way of writing a segment name. Section name. See, now I'm getting those two confused again. I feel like they're these sort of arbitrary pairs that are very easy to get backwards when you think about them the wrong way. And then I've got to go read the header file again. Oh, interesting. Is this Lucas from before with the tablet joystick emulation ideas? And they're wondering how you would connect a Raspberry Pi to a PC to recognize it as an input device. That's a good question. You might be able to use some kind of USB on-the-go mode stuff for the Raspberry Pi. I don't know how painful that's going to be. It might involve recompiling your kernel. It might not work at all. Like, I don't know if that's actually supported. The easiest way to do that might involve using maybe Bluetooth human interface device emulation. Like, you could maybe have the Raspberry Pi pretend to be like a Bluetooth LE human interface device, and then use the existing Windows driver for that or whatever. You might also find some software solution that lets you take like serial data from the Raspberry Pi and convert it to input events. I would probably look for some kind of workaround like that, but yeah, I mean, maybe you'll find USB device emulation support for the Raspberry. Yeah, that's good advice from Zimzel, who says Google for USB gadget and on the go. Yeah, those are the keywords you want. USB gadget is what Linux calls its subsystem for being a USB device as a Linux device. If this is the same project you were talking about before, I think part of the reason for the Raspberry Pi in this case, rather than a smaller microcontroller, is that you also want the USB host. So it's a project where you're talking to USB input devices, but also emulating USB input devices. So yeah, that might be a good use case for something like USB gadget, but I don't know how finicky that's going to be on the Raspberry Pi at the moment. Alright, I think I can close this for now. Alright, now we got some failing test cases. Okay, these are failing because of that stack alignment check that I added. Apparently, in a lot of these, the stack was misaligned, but just nobody cares. It's not misaligned enough, right? It's always going to be 8-byte aligned because it's all. I mean, I'm already aligning it to 16 bytes, and then the length of the variable section that is causing it to be misaligned is always a multiple of 8 because it's always, in this case, 64-bit values. So a lot of things don't care about anything greater than just 64-bit alignment on a 64-bit platform, but the crash I was hitting on one of these other test cases, I think if I run the Ubuntu test directly, we'll get that particular crash and we can look at it closer. That was crashing because of an MMX instruction. Well, so now it's not hitting that crash because I have the assertion. Maybe we'll turn off the assertion temporarily. I just wanted to get a fresh Emacs after closing all my other ones. Oh, why don't I have my right-click window? I think it had to page back in. That's funny. Oh, that's handy. Yeah, I bet USB-C would make gadget stuff easier because you don't need a special cable like you would with USB Type-B on the go. Oh. Okay. Yeah. So this test case succeeds LDSO aux-v, and LDSO is the one that crashes currently. Success, and oh, I am not in the directory that includes that code. Oh, this editor is hogging the build lock. This is when it'd be great if Tuco's around and we could just pet the cat while the computer does its computering. Be gone, spammer. Yeah, I think part of what's interesting, or what's maybe difficult about this this thing where you need to be like a USB host and a USB device, is that the USB host part is much easier to do with a full operating system, and the USB device part is much easier to do without a full operating system. So you kind of are working against the grain either way. I mean, this is not like a fundamental truth of USB, but it's just like how things are currently with the libraries that are available. Okay, that's what we wanted. So, just as an example, if I add just any arbitrary environment variable here, in fact, I think any additional argument would also make that test pass. No. Oh, this failed later on. That's fine. This will probably also fail later on because it's probably going to try to run a program called blah. Nice messy crash. Yeah, so I don't know where this is off the top of my head, but it's probably not the same crash. Doesn't look like the same offset. So let's go back to reproducing the crash and not checking the stack alignment. So that's the stack alignment check I just added. I should really make some constants for the actual stack alignment amounts. Alright, I need to put something after this stack align that inserts additional alignment padding. It's just awkward because the point that I actually want to be aligned is this final SP value, but I don't have all the information together that I would need to work backwards from there yet. Part of what this store vectors thing is doing even is just buffering some pointers that we know we need to write to the stack, but we don't actually have the address for yet. So the pointers have been computed way up there, and then here we're actually copying the pointers from the temporary buffer to the actual stack. Chris is wondering what determines what the stack alignment is. It's usually part of the architecture specification, so if I wanted to be pedantic about this, I could probably find it somewhere in the ELF AMD 64 specs. But it's defined by the architecture, and the place where you'll find that it's necessary is when code, usually code generated by the compiler or code deep inside libraries, makes assumptions about the alignment of data that it's pushed onto the stack using like whatever stack pointer you gave it. And so in this case, I was getting a crash in some MMX code, which we could take a look at. So, these are so ugly right now. I think this is the spot. This is actually probably easier if we reproduce this without using the unit test, if we just use the command line tool. It's part of why the command line tool is handy. That's not even, really not used to the paste behavior on this particular Emacs. Okay, so that's the specific image we wanted. And then I'm just trying to run the dynamic linker directly. So this should just give you a little message if it works as it should. Yeah, I think that's a pretty good suggestion from C. Krangos in YouTube chat. That yeah, the teensy is actually super convenient to use as a USB device emulation, just because of how well it's supported with examples and libraries and things for that. Okay, let's just verify this is the crash that's behaving as we expect. It's a little easier to play with it in the command line here. So let's try adding an argument, like just any argument. So now it's still sig 11ing, but at a different place. Let's try adding something that might be interpreted as like a command line option. For that, I've got to escape it here, but then that help should go to the actual LDSO. also looks like not the crash I'm looking for. Let's try adding 2 copies of that, just in case it's a even odd kind of thing. No. Okay, so then the other test case we had was no command line arguments, but environment variables. So let's just put these over here. Let's just set something random first. So that's sig11's. That's a different sig11. It's a null pointer. Let's set this flag, ld show auxv. Why is this not working? This was a control experiment. This was supposed to work. It is really bad, like the exec implementation right now is really bad at reporting errors. So it can crash in some strange ways if you try to exec a program that doesn't exist right now. But I don't know if that's actually what we're hitting. Let's just run the test suite again to make sure that things are still cool, except where we expect them to be broken. Oh, cool. Chris said they started reading some of the code for this the other day. That's neat. I'd be interested if anybody has feedback. It certainly needs more documentation and more testing, but it's just one of these things where it's just this unwieldy, complicated thing that I've been trying to get working where I can, and so it's certainly in a work in progress state. Gosh, I have this whole other build tree with whole other problems right now. I started working on this on 2 different computers and just like went in slightly different directions. And so here I was working on the stack alignment issue, but then elsewhere I was deciding that I really needed to refactor some of the code that's bothering me. There's this protocol module that's used both by the sandbox runtime, the really low-level code that runs inside the sandbox, and it's used by the higher-level IPC server that provides file system access and like external I/O. And so far, the way this is doing it in this code base that actually compiles, it's literally just doing like a textual include of the protocol file from one crate into another crate, which is very dirty, but it was the way that I got this working when I was tired of messing with it. It seems like it should be possible to separate that protocol into a different crate that both the insides and the outsides of the sandbox depend on. So I was trying to do that. It's just a little bit weird because of the nested build that I do to compile the innards of the sandbox. But I think I can get that working. But now I've got a source tree that's like partway through that process too. Anyway, this is where I expect it to be. So I just want to reproduce this Ubuntu LDSO auxv test now on the command line. Oh gosh, it's so wide. Can we make this bigger but less wide? Whoa. Amazing bigness. Okay, that looks like the right hash. LT show oxv equals 1. And except for that typo that wasn't there before, that looks like the right file name. Well, that is annoying. Oh, who's trying to call bin/bash? Oh! This container probably has an entry point set, which would prepend like bin/bash-c or whatever to the command. If that's what's going on, though, I would expect the same behavior in the test case and the CLI, though. But let's turn on more logging. Definitely trying to exec bin bash. Oh, that's weird. Oh, maybe this is a problem with the command line processor. This is showing up as an environment variable, which really should not be the case. That is weird. Yeah, I don't know if this is an entry point thing, actually. This might just be the command line processor doing the wrong thing entirely. How? So -e is not stopping where it should. That's cool. I probably just misunderstood something in the command line processor configuration here. Yeah, it was trying to run the rest with bash, which is certainly not what I want, and it's not going to work. Probably for the same reason that, like, most libc programs that are dynamically linked right now are crashing in this same way. But that's not a surprise because I'm not really supporting dynamically linked programs yet. The kernel is supposed to invoke the interpreter, and I haven't implemented that yet. So I'm trying to work with statically linked binaries and position-independent binaries, which are basically statically linked, but from the kernel's point of view, they look a little bit more like they are the dynamic link interpreter. So that's why I'm also running the dynamic link interpreter, because that, from the kernel's point of view, looks a lot like running any other statically linked position-independent binary. This is the command line argument parser. that I'm using. That's what I don't want, right? That's exactly the problem I'm hitting. Okay, thanks, pro tip. Am I hitting this problem anywhere else? I should really have integration tests for the command line tool. I don't actually have those yet, because Rust doesn't make that super easy to do, but I should probably do it anyway. Actually, there might be some documentation in this crate on how to do testing of your command line interface. Like, the kind of traditional thing to do with Rust is to have like a library that does most of the work, and then you can write unit tests and integration tests sort of within and around that library. And then you have a really simple command line interface on top of that, which is what I've got here. But now I've got a bug in my very simple command line interface. Gosh, that is weird. Number of values. Oops. Okay, so args, that is actually fine, because that's basically just my positional, like, everything else argument. So this is really only a problem with the environment right now. I think that's what I was missing. Oh, I miss Tuco. He's probably cold now. He's probably off at the other end of the house where it's much warmer. Oh, yay. That is working. So we've got a bunch of debug output. And then this is coming from a debug option that I gave to the dynamic linker, which is this ld show auxv. This is printing out the auxiliary vector contents. So that's cool. That's cool and good. Some of these are fake, like all these zeros. Well, I mean, I think that's supposed to be 0. I forget what this actually means, but I think it's supposed to always be 0. These are fake. But that's right, and that's right, and that's right. This is actually a pointer to a random buffer. It's not just a random number. I think that's right. I fixed that recently. That should be right. So we've got some good values here. So like this is the VDSO page, which is a kernel resource that we use to do things like get the current time very quickly. This is the hardware page size and a completely arbitrary tick count that isn't actually real, but we're using the same fake value that Linux uses. You know, it's always such a mix of stuff that is critically important and just like random legacy stuff that nobody cares about when you're working with interfaces like this. But yeah, LDSO. So let's see if I can reproduce the crash by just taking off that parameter. Oops. Looks like it. think that's the same address, 26A7. Anybody have recommendations for like help forums for microcontroller stuff? I think Adafruit has some stuff like that on Discord. Curious if other folks have recommendations. Let's see if we can definitely reproduce this by just adding and removing environment variables. So here it is, crash occurring. Let's add just an arbitrary environment variable. Now it's not crashing. Let's add another arbitrary environment variable. I think it can even be a duplicate. I don't think we care if it's duplicate. Maybe we do. Yeah, now it's crashing again. You can see the environment variables right there on the stack. Now it's not crashing. Yeah, so that's our stack alignment issue. And the length of these should not matter at all. It's just the number of pointers we're pushing right now. Can we pass parameters to LDSO? I think most of these are not going to do any good without loading a program. We could try loading a program. That's probably a different crash. No. That is actually the same crash. So yeah, let's try taking out a pointer to balance our stack. That's a different crash. That's at 30B3. I know this just looks like a soup of hexadecimal numbers, but the most important values here are the instruction pointer the crash was on. And then because this is a position-independent binary, this is actually randomized, so you actually have to subtract the beginning of the text segment to get an actual address that'll make sense in your disassembler. So that's this value here. You can tell it's the executable segment because of the X flag over here. So, and usually there's just one X segment that's actually mapped to a file, which is path in this column. There's also this other X segment called VDSO, which is the one I mentioned earlier that's used for like getting the current time mostly, and the current CPU ID and stuff like that. And then vsyscall is similar to VDSO, but it's like an older deprecated way of doing system calls that Ubuntu still emulates for some reason. Oh, cool. Apparently PJRC, who do the TNC, have some good forums, so that's a good recommendation. Yeah, they've got some good stuff, and it's always very easy to use relative to, I think, so many other microcontroller systems. All right, well, let's maybe check in some of this. What a simple fix. Number of values 1. I think I had that set to Pico partly because I found myself running a terminal inside of Emacs a lot, and then I would find myself running like a nested copy of Emacs inside the Emacs terminal, which is actually not very fun to type in. Then again, the nested Pico isn't very good either, so then I just tried to stop doing that. There's probably a way to get the editor commands inside the Emacs terminal to open up a separate window in the same Emacs, but I didn't really explore that. Okay, so we've got that stack alignment thing we need to deal with still in this test case. I'm starting to add something to deal with it here, but I don't even know if this is going to help. Maybe it will. Let's actually verify that the stack alignment is correct and that it shouldn't be something... I mean, I'm pretty sure I looked this up and it was 16 bytes, but it would be useful to have an authoritative reference for that on the stream. Let's watch somebody else make the exact same mistake. Eight mod 16. That's weird. Does that match what we were seeing? What is this? Input argument area. I don't know if this is the same version of this document I was referring to before. I think that this is the normal function call standard, not the process entry standard, because this is not how argc seems to actually work. So I might just be confusing myself with differences between program setup and the actual procedure call standard. That's right. Like if you need 8 bytes for your return address, and then you want your arguments to be 16-byte aligned, that makes sense. But like on entry to the process, you don't have a return address in that slot. Instead, you just have argc and then argv and so on. Yeah. This is the chart I was thinking about. Initial process stack. So the initial stack pointer points to argc, the argument count. Below that is unallocated, and then above that is a bunch of other stuff. So the argument vectors, the environment pointer, the auxiliary vectors. So right now I have a sort of a pin I'm putting, I think right here, right between the unspecified region and all these vectors, saying that that's aligned on a 16-byte boundary. But actually, what I think the spec is going to tell me is that this needs to be aligned on a 16-byte boundary, but I want to actually find that reference. It's also kind of illuminating, reading these specs for the first time, that like I was kind of surprised to find out about like the way the environment and the auxiliary vectors are just sort of tacked on to the end of argv. Like if you just read past the end of your argv array, you will always find the environment and the auxiliary vectors. Just normally programs don't do that. Okay, that's what we're looking for. So RSP is guaranteed to be 16-byte aligned, which is exactly what my assertion says. But we can make a note of it now. Okay. Do we have any other alignment kind of things here? What about elf things? Okay, elf stack line. That's nicer. So I've got this concept of a program loader, which is a relatively high-level abstraction for all the stuff that you might need to do to a process and its address space in order to load a program into it. So the format-specific code here, ELF64, is calling methods on this loader interface. But then under the hood, it's got a bunch of other pieces to it that are actually implemented in separate modules. And like one of those is the stack builder. So you can start building a new stack for the process by calling this loader.stackBegin. And then it gives you this object that keeps track of the state of this stack that you're working on. You can add things directly to the new stack, like stack bytes or stack random bytes here. Stack remote bytes to copy stuff from the remote process. This is all a little bit awkward under the hood because we don't have direct access to any of this memory really. We're just like remote controlling another process via ptrace to get it to do all of these things. So stack bytes is actually kind of complicated. Stack remote bytes is simpler because we're building the stack in that remote process already. And so I wanted to have a way to hold on to the vectors in loops like this in a separate little pouch of memory while I store the actual strings and calculate the rest of the vectors. So here, like, I'm looping over all the arguments. While I'm looping over the arguments, I need to copy the argument contents, but then also hold on to a pointer to each argument using this store vectors. So there's this accumulation of vectors that gets stored up in the loader. And then you can flush all of the stored vectors at once to the stack. So I'm putting in vectors for argv, for env, and then the aux vectors. And then I'm flushing those all to the stack right here. So I could easily calculate how many total vectors I have by looking at whatever's currently in the store, like before stacking them here, plus what I'm doing right here, which is just argc. And then I don't want to stack that 0 as another vector because that would put it at the end of this list rather than before. But if I could stack those bytes directly, that would actually just do what I want. Is there like a stack.skip? So if I could move ahead a specific number of bytes, that would be basically exactly what I want. Internally, that is a memfd that I'm p-writing and p-reading, so it's got full sparse file support. It's actually kind of a handy data structure. It just means you're doing a system call every time you access it. So right, like a line just changes this pointer. It doesn't actually write anything. I'd be doing something similar. I feel like I should separate this into specifically number of bytes and number of vectors, or like count. Stored vectors count and stored vectors bytes, maybe. Oops. This is much more like pad than an actual right, or like a line. I like this condition or convention of returning the new pointer at least. Looking to see if there's a piece I can remove from push remote bytes to do this. Yeah. I'm going to make push remote bytes call skip bytes internally. Avoid copying this piece. And this can fail because the stack can overflow. I mean, there isn't necessarily like a good reason to have a hard limit. It just seems like a good, it's good to prevent an arbitrary amount of memory from being allocated. But this limit can be fairly arbitrarily large. I think it's a couple hundred megabytes right now. Sometimes I want the pop-ups to go away so that I can just think about the code. Yeah, I mean, that could be more compact, but I think keeping those separate makes it easier to understand. Oops. Yeah, elf stack align. I'm debating whether to do like one kind of absolute alignment here and then to insert padding, or whether I want to actually like query where the stack pointer currently is. That seems just more error prone though than doing the alignment. Kind of nice sometime to have like a type for numbers that are a power of 2. But I'm just going to do this a little bit more old school. This is another piece that's like different just because I needed a temporary place to store the value, and then like I don't know argc until after I've walked through these arrays. So I stack it separately. that. I don't know if I can do that. Is there a reason I'm using a bit and instead of a mod? Because a bit and is the operation I wanted. Could use a mod. Like, I don't find it super useful to think about operations which are like slicing binary numbers into pieces in terms of modulo. It just feels like the wrong level of abstraction. Like, yeah, I mean, you could write the code that way. It would compile to the same thing, but for stuff like this, I just find like bitwise math to make a lot more sense. Yeah. I feel like there's gotta be a nicer way to do these generically. Like, if I was doing this in more places, I would definitely make a bunch of utilities, but right now I feel like the extra dependencies are not really worth the extra, or they're not really worth, like, tying modules together that I would otherwise want to be distinct. Oops. Okay, that was a different crash. This is working with 2 environment variables, 1 environment variable. Yay. How about 0 environment variables? Yay, so I think that fixes the stack alignment issue. I never actually showed you the code that was crashing. Do I still have it open in the disassembler? Let's get that address. I can at least show you why the alignment mattered in this case. It'd be cool if Tuco came back before the stream was over. Okay, so same example without that patch crashing. So the address, if you subtract the base, would be 16A7. Oh, is that right? Doesn't look right. I must not be doing this right. That's not an actual instruction. It's weird. This looks like the right binary. Oh, thanks for the delightful winter wishes. Yeah, Tuco's been staying nice and warm. He seems to like the cold weather as long as he's got a warm blanket to stay under. That sure looks like 16A7 to me. I thought we were getting something that started with a 2 last time. What is 26A7? Yeah, this is the crash I was looking at, which makes much more sense. Why am I seeing it as 16A7? Oh, I forgot to add this offset. I just can't do address math, apparently. Yeah, it's instruction pointer minus the physical base plus the file base, because these are file addresses, not segment addresses. I was calculating the address relative to the beginning of the memory segment, not the address in the ELF file's address base. So yeah, the address I remembered was correct, not the address I calculated. And that was 26A7. So that is an instruction, and it is an instruction that requires alignment. So this will crash if RBP is not 16-byte aligned when you invoke this. And we can look at RBP. BP over here, it is not 16-byte aligned. So that's catching it red-handed, basically. All right, let's put that patch back since it seems to do what we want. Cool. I think if we run the test cases, they will fail later on because the output is no longer empty. Let's see if that actually is the case. I can't just do an equality compare here, though, because a lot of the numbers in that output are randomized. It's true. I like bundling up. Potentially more than Tuco likes bundling up, even. Build and test. Yeah. I've been close to adding some utility functions to get strings as the output, since it seemed more correct and more in line with how regular subprocessors work in Rust for the output to be byte vectors. But sometimes it's just more convenient for them to be strings. Sure is some compiling. Oh, that little spinner is annoying. Oh, that's important. Forgot a question mark right there. And that, I think, is fine. So in both cases, we're getting the help message, which I think always gives me this status code. So it looks like the help message comes out over standard error, and then this ld show auxv output comes out over standard out. So I'm not actually checking the output, I'm just checking that it exists. One of the next steps will be to write some regular expressions for that test so it can actually check the parts that I want to check and let some of the results vary. Gosh, this is a bit slow right now. Probably running low on memory. Guess I could close some of my million web browser tabs here. Can I close all my browser tabs? Don't know why we're having a close button failure. I'm inclined to say it probably just needs to swap back in because everything's probably paging right now. This might actually be a problem. The mouse cursor was freezing for a sec. Do I need to SSH in and kill processes? Whew. Oh, is this just a different tab? Is this some running Docker containers I had forgotten about? I don't think I need these right now. Okay, I think that's ready to check in. It's nice that this runs in whatever sort of container the GitHub Actions are using, so I can just use their CI. Okay, I think that does it for this tree. Now I've got a bigger mess to clean up. Yeah, I'm just starting to try to extract the um, protocol into a separate crate, which seems to be a useful cleanup step. The biggest change that's involved is previously I had been defining some traits on my low-level system file descriptor object, which lived in the protocol, and some of those traits required the standard library, and so those were defined only in the high-level code that used it, not in the low-level code. There's multiple ways of fixing this. Like, I could keep that same architecture and add a feature flag to the protocol so that I could compile it with or without standard library dependencies. But it seemed like closer to the architecture I actually wanted if the couple of places where I needed to add like standard library specific features to the file descriptor, those were actually wrapper objects rather than just traits that were added to the existing file descriptor object. So that's where I was going with this messy pile of code. Let's see if it'll merge with that code, that change I just made. Seems fine. Okay. I need a really quick break to refresh my coffee and see where Tuco is and use the restroom and all that, but I'll be right back. Hi. Tuco's napping in this nice warm spot on the opposite side of the house. Brr. I made most of the changes, like the fundamental changes, and now I'm just fixing the errors where the compiler tells me that things need work still. So this is moving a lot of things from nolibc to this file struct inside nolibc, and it's moving the protocol file, but not actually splitting it yet. Sign into view logs. Interesting. I don't know how many of those messages I'm getting from RLS are new errors. I was just having some RLS problems with the editor before, too. Okay, are these errors from sand? So many of them. This is like recompiling this part again, because before I was doing the nested build, but then the nested build is pretty annoying to debug in its nested form, so doing it outside the build RS is usually useful, but then you're using a separate target directory. Yeah, okay. Let's work on these. think most of the places I'm using protocol sysfd directly, I'm probably going to end up switching to nolibc file. Nolibc is another one of these parts of this project that I might split off into a separate crate entirely at some point. Because it's basically just utilities for operating in a world where you're not actually using the C standard library or libc. So it has some like really simple alternatives to libc functions for things like opening files. I also just hadn't really decided, I don't know, there's this weird piece of Rust where, like typically when you maintain ownership over something like a file, that ownership of the actual Rust object matches the ownership of the underlying operating system object, and so when you drop that Rust file object, it closes the operating system file. That's normally how things work. But the way Rust supports raw file descriptors, which are used when you're dealing with like really low-level operating system interfaces sometimes, the raw file descriptor is just literally an alias for an integer. It doesn't have another struct around it. So the raw file descriptors can't track lifetimes. They just refer to the number that the OS uses to represent the file descriptor within your process's file descriptor table. So I kind of haven't decided which parts of that I want to emulate, because like I'm using separate types here. I could do it differently. The way I've been doing it so far is I've had this sysfd thing, which actually is like a new type object. It isn't just an alias for an integer, but it is just like a tuple struct in Rust terminology. So it's a very simple wrapper type, but it's still like a wrapper type around an integer. And so that's why it was even a viable place to put things like a write trait before I decided to split things up differently. But I've been kind of assuming that maybe at some point I might change how sysfd works, and so I've been trying to use like references to it in some places instead of copying it, but that started to get kind of annoying, and I feel like at this point I'm kind of committed to sysfd being a type which is cheap to copy and doesn't actually involve ownership of the underlying file object in the kernel. But then that means that if I have this file wrapper around the sysfd, maybe that's where I want the ownership to be. So if I'm adding that layer right now, maybe that's when I make that change. But also, all of this code is so low level that there are very few cases where I do actually want to own the underlying file directly. So maybe it does make sense to do it at a different level like I've been doing. Where else do I even use sysfd? Feels like I use it in a lot of places. Basically. So there's the IPC socket, remote FDs. Oh gosh, this whole parser thing. So, like, this IPC socket, I think that could take ownership of its file. It doesn't especially matter because this socket lasts for the entire length of the program, so like we never need to delete it, and if it ever closes, we are exiting the server, or exiting the emulator anyway. I guess I just keep coming back to how, like, I want it to be possible to refer to a file descriptor that you're not also responsible for closing. And it feels like this file object I'm starting to add, or this file struct, that's like a useful place to hang a bunch of methods that are related to doing things to files. If I made the same object also responsible for owning the file, like, it really seems like I just need to make a separate thing that is like an owned file. But in practice, I haven't needed that because the other objects that encapsulate some kind of file-based behavior are the ones who are responsible for closing the file if they need to. So this feels like I want to replace most of the sysfd usages with file, but still have it behave roughly the same. And I could also, of course, have the file have like a runtime flag indicating whether the file should be closed, but that seems especially bad. It seems like instead, if it wanted to take ownership of the file by default, there should just be a way of disposing them without closing the file. That would probably make more sense to have that not be the default. Some creepy eyes there. They kind of look cute and reptilian, though. Like, that should just be new. This SIG.io stuff is kind of weird. It's probably going to be in this category of kernel interfaces that are allowed in the tracer, but not inside the sandbox itself. But if I want to support applications that use SIG.io, like, it's not very common, but if it turns out something I care about uses it, like, I'll probably need to emulate it somehow. Right, like, I'll probably have a system call filter set up once I reach the point of having those filters more audited. Like, I'll probably have the filter set up so that specific calls like set own are not allowed, because that wouldn't even make sense, because the process inside the sandbox doesn't even know about real process IDs. So this has to be translated at the least, but I think even the tracer is not a process that I would want to trust to be able to send signals to arbitrary other PIDs, right? So this would actually have to be administered by something a little bit higher privilege, like the IPC server. That's definitely something I need to fix later. That's cool. This is just for communication between the protocol and like the socket layer behind the protocol, so I guess I do just need this to be sysfd. That feels like it could be a sysfd also. Surely I can just drive equal for those. These directory entry iterators are a little bit weird. They can't just return a reference to the directory entry to something external that's iterating, because that that reference wouldn't last long enough. Like, it could make another copy just to return it, but the approach that I decided to do instead of copying that was to have like a function argument, which in this case is this closure, which gets called with the copy that's already in the buffer, like while it exists. And then so if you wanted to, you could just call clone and make your own copy of it. But usually you're processing it somehow, so you can do that processing in the closure and then return a new object that can last longer. And then that gets returned from into this result by the iterator. It's a bit weird. This is iterating over proc self fd to close unnecessary file descriptors. So I think I can go ahead and open this file, or wrap this with a file. Why is it counting these? I think I wanted to make an exact count of the allowed files here. That's better. Can I be more specific than just file here? This is the socket. And these are the args. Man, DUP2 is such a weird corner of Unix also. You can create a file descriptor with whatever number you want within limits. I'm gonna make this a slice of references again. That's already a reference. Where do the errors even start? Oh, parser is definitely going to have a bunch of problems still. I don't know if parser needs sysfd. This is a somewhat higher level module. This is the parser that's used for reading proc files. It's a little bit specialized because of how proc files are, and so that it doesn't need memory allocation. Yeah, it's for parsing stuff like this. Oh, this is a pretty weird thing to do. Like usually sysfd and remote FDs are totally separate, but you can actually create a remote FD from a sysfd if you pass it through your process inheritance, which is what this is trying to do. How public is this? This is not actually public API stuff. Private? Really? Did I forget to make file public? I did. was technically in the public API. If I was being super pedantic about this, I probably would try to keep everything but the bare minimum out of the public API of the sand runtime. But like the entire sand runtime is considered an implementation detail, so that's probably not necessary. But like this will show up if I update the docs for this crate. Like this is what it looks like right now. It's not, doesn't look very public, right? It's like unsafe cmain argv. But feels like I probably should just expose that and not the entirety of that file object. I guess that makes more sense as not an associated function, but just a crate function. Okay, no change. Sounds pretty windy outside. This is reading the elf header, or like the binary header of whatever sort it's going to be, but the way the binary identification code works in Linux, it's just got a fixed size buffer that it fills with the beginning of the file, and then it sends that buffer over to every prospective binary format module to take a look at it. So we do something similar here. Process handle. That's part of the protocol, isn't it? So protocol stuff cannot have file objects in it. It has to be a sysfd there. Like I could make another version of this that just has all the sysfds replaced by file, but that seems silly. That's the only place I actually read the memory file. I think everything else is based off of that. Args file. Oh yeah, this piece of code is weird. I found an implementation of alloc A in Rust. I don't know if I'm going to keep doing it this way, but this is currently how we put the argument buffer somewhere temporary in the address space of the process that we're about to replace when the very first exec happens. So all the argument and environment and everything for the process temporarily gets stuffed into a file, in order to, not like a real file, but like a kernel file object. In this case, it's a memfd. Or no, actually it's a socket pair. So yeah, there's a socket on the IPC server side that's writing the arguments and environment, and then a socket on this side that reads it. But it's got to stick it in our address space somewhere. So we're just sticking it on the stack, which is where it goes eventually, but it's not the nicest thing to do in Rust right now. So yeah, we might switch to doing that with malloc at some point. But right now, alloc A seems to be fine. And there's the actual exec. This is like the last piece of startup code that runs inside the emulated process before we actually transfer control to the program we're trying to run. But this exec syscall is emulated, so like at this, a lot of the stuff that's happening on up at the top of this function is just sort of running in user space on memory with only direct system calls like read and write. But then changedir is going to be emulated, execve is going to be emulated. And at this point, we unmap all the memory and replace it with the new process. Okay, these are the standard I/O opens. Oh, that's sandlib. I'm slightly annoyed by all the places where I have to have all the standard I/O streams listed separately rather than just dealing with an array of 3 file descriptors. This does not... That should be a reference to file. Oh yeah, this is that. I mentioned this much earlier in the stream. This loader is sort of like a bit of a veneer layer over some of the innards of the task and memory management systems here, in order to give the individual binary loaders, like the ELF64 loader, a consistent interface. That's actually kind of handy. I think this macro has already got a good spot for me to put this wrapper in that converts a sysfd to a file. This macro always looks a little bit weird when I'm dealing with replies that only have a single value in them, because it's like, well, why do I need this extra parameter? Why couldn't I just stick that on the exterior of the IPC call? And that's just entirely because, like, this is a pattern, and the pattern might contain multiple values in it, and you need to have exactly one value, not like 0 values or 5 values or whatever here. But it means that some IPC calls end up looking a little bit more verbose than maybe it seems like they should. Oh, Tuco, you're back. Hey. Hey. Hey, little guy. Oh, oh, such a cat. What do you have to say, Tuco? Oh, he's starting to purr. Oh, Tuco. Alright, Duke. See you later. Tuco, you're back again. Do you want this open? It sounds kind of like it's raining. Oh, it is definitely raining. Does Tuco want to check out the rain? Very briefly wants to check out the rain. Tuco, do you want more of that? It's funny, he seems to eat that food more reliably when I leave it in that package. Like if I just dump it all out, then he usually doesn't eat all of it, but if I leave it in there, he cleans it eventually. He still kind of makes a giant mess of food. Little bits of meat everywhere. Tuco. We only have read file and not read file exact here. Yeah, that's actually not what I wanted. I did actually want something more like read file exact right there. So right here, I'm actually kind of okay with ignoring the return value of pread. So pread can give us less than the entire buffer full, but in this case, this is sort of an arbitrary size buffer, and we're just looking for magic numbers in there. So having 0 is past where the file actually ends seems kind of fine. But for the other one where we're reading program headers, that really should be an exact read. I could include a regular non-exact read file, but I don't think anybody would use it. Hmm. Forgetting who uses task socket pair. All right. This is specifically a socket pair that we're passing into a new task that we're creating. It is weird that it has to be clone here. I think that's because of how we're initializing the process table. Like, what if this was not clone? It's actually a little weird right now that the entire task state is clone. Just task data, really. Task data is the part of the task state that we pass in during initialization. I don't know that task data needs to be clone either. I think we're going to find the reason why all of that has to be cloned now. Maybe not. Well, maybe we can try doing it that way. Well, maybe we'll find a problem with it later, but let's just take these from the beginning. Hey, Tsuko, you want this open again? Brr. Tsuko with a coldness. Aw. Yeah, it's cold, right? Hey. Whoa. Hi. Coming up. You're looking for cat food in the trash can, honey. Are you going to sit right there? What? Yawn. You gonna get cat fur in my coffee, honey? Neck massage. Purring. Hmm? Oh, Tuco, it's still so cold. Do you want this door open? Purr. Aw. Yeah? Where to? Green cat. Yeah? Do you want me to open this again? I don't think he does. I think it's cold for him, too. It's the Tuco tripod. He's back over here now. It's kind of an inconvenient spot to film. He's like right behind me now. That's better. Why is that a search? Huh. Oh. These tests are a little weird because it's using the standard library for the tests, but it's testing code that is specifically for use without the standard library. That's why I have two file objects in scope here. It's a file descriptor of a directory of file descriptors. It's a very Unix sort of object. I think that does actually want to be a sysfd. Yeah, so this is another way of getting a remote FD, is to send it across. I mean, I was going to say some kind of communication channel, but this is even weird for our standards. The way this sends a file descriptor is by using this pre-existing socket pair that we established before forking off this process, but then making a remote system call in order to receive a file onto that socket from the remote process's side. So it's a little weird. Right, file reply should be a result. Oh, it's that question mark operator. Gotcha. I guess I could always put the question mark there. That might be slightly more clear. Let's make some space. Oh, Tuco. You're back from R. Ah, Tuco, it's cold. Focus. I think he wants me to leave that open so that he can sit on the warm blanket and enjoy the cool breeze while I'm over here actually next to the coldness. Right, this does a pretty low level everything, really. So like this is a local send message and then a remote receive message, right? Yeah. can get away with that because this particular thing never needs to block. Like, it's async because we might need to wait to do the receive system call, but the send is always into a socket that has buffer space for a file, so we can do a blocking send and it'll never actually put the process to sleep. Hey, Tuco. You're just right back over here. Dude. Yeah, you want that. I got it. I think he specifically wants the door open even though he's not next to it. I think that's what he's asking for, but I'm going to have to disagree with him. It's like fighting over the thermostat with my roommate over here. You're back again, Tuco. Ah, here's another place we're using the mem file. I thought this was kind of cute. I can use the same buffering system that I wrote originally for the proc file system parsing in order to read null terminated strings out of the sandbox process's memory. I don't know if that's going to survive long enough. I think that's going to be a lifetime problem. This is one of those things that doesn't really matter as long as a file is basically just a wrapper around an FD, but would definitely change if I was trying to make file behave in more of an RAII sort of way, or like a resource acquisition as initialization, so that it drops, or so that it closes the file when I actually drop this object. Oh, 2 goes over there now. Is the camera focusing on the reflection? It's kind of cute. Is it focusing on me now? There we go. Oh yeah, there's a good question about the byte reader, if it's this like byte-wise parsing operations that you don't need a big buffer. Yeah, exactly. The idea was that I wanted to do all my parsing as just like a strict byte-by-byte state machine so that I could handle, like, the main thing I was trying to consider here is that I want to be able to read files like proc self maps extremely reliably, even if the file has arbitrarily long paths, and even if I have a limited amount of memory to use. So I ended up writing this as like a byte-by-byte parser state machine, which is most of what this is doing. But because you don't want to have to call read for every byte, it does start with an input buffer, which is what this byte reader sets up first. So yeah, usually it'll just read like 256 bytes at a time or so. I don't know, I feel like it's cleaner for this to reference a file, but like it feels more practical at the moment for it to own a file, really. Yeah, that seems fine. Yeah, it took me longer than I really feel proud of to decide what kind of parser to use for that proc file stuff. Because at first it seemed like I could use nom, or maybe one of the other parsing crates I could find in Rust, but I didn't see something that was the right mixture of features. Like on most systems, it's like usually the performance trade-off folks want is to assume that things are in buffer for the most part, and then to like fail and get more data if you don't have enough. Like that's the approach nom uses. But in my case, I always wanted to parse things byte by byte so that it would be easy to use really small buffers while also like keeping the same guarantees about what input I can handle. Tuco sure is meowing. You're asking for the door open again, honey. Yeah. You're gone already? Tuco, you're so weird. Honey. Such a cat. I think Tuco just wants me to be cold. Let's close that again. Tuco, 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 Tuco. You're back already. Oh. Now he's knocking stuff off the other desk. Oh, we've got a perfect opportunity for video feedback, though. Meow. Why is my phone buzzing? spam. Gosh, is everyone getting those spam calls these days where like, the phone number is numerically very close to yours? It feels like folks are just getting random phone numbers and then like dialing whatever is nearby in the exchange. Oh, Tuco. Oh, I got a visitor on YouTube chat who's here after trying to look up how to disassemble their Wacom tablet. Welcome. Yeah, a lot of people seem to like those videos. That was a while ago, but there's always more tablet stuff to explore. Maybe it'd be worth doing another tablet project. Oh, Tuco. Do you want the door open again? I usually don't bother answering them, but a couple of times I have, and it's usually some pre-recorded scam. Like, what are the ones that they're usually going around? There's the, like, something or other, your social security number has been terminated or whatever, and they usually are in, like, voice synthesizer apps and have grammatical mistakes in them. It's, like, pretty low-effort spamming. Yeah, here's a test case that's using a 1 byte buffer, just to make sure that works. Specifically, it's using a 1 byte buffer and then making a bunch of reads that are specifically designed to make sure that the snapshot of the data that we're reading from the kernel doesn't change between reads, because that's supposed to be guaranteed. The proc file system in Linux, for the most part, has this weird set of rules where the data that you're reading is actually refreshed either when you seek to the beginning of the file or when the file is opened. Your SSN has achieved consciousness and the CIA wants your help to stop it. Yeah, basically as believable as the spam that they're sending out. Yeah, they're definitely using temporary phone numbers that they dump. Zimzilla asks if this is a thing anywhere outside the US. Apparently it is. Yeah, I wouldn't expect this to be unique to the US, but I am a little curious how the differences in telecommunication regulations would affect it. FD file, not quite. Ooh. This is also a very meta test case because we're actually inspecting the kernel's notion of which system call was used to read this particular proc file. So that's why we're actually asserting that the arguments here are things like pread64 and the particular file descriptor. This is actually used, but only from the test cases. Oh well. Oh, that's interesting. No automated telephone spam in Austria? Weird. And then Reboot Lover adds that in the UK there's a service called the Telephone Preference Service where you register the number and theoretically the scam caller shouldn't touch you with a barge pole. Yeah, I mean, we have like a do not call list here in the US, but it's supposed to be regulated by the FCC, which mostly doesn't regulate anything effectively anymore. So it's like basically everything in the US is run by whoever has the most money, right? And so the wireless companies don't have a huge incentive to actually do anything about the spam. It's not like you can switch wireless carriers and get away from the spam here. Oh yeah, and Pandemia adds that in Argentina they have a no llame list, do not call. Just keep messing up these same couple of lines of code. Ah. Oh, fine. Let's just do it the other way. Oh, interesting. Platypus says that this kind of spam is easier in the US because of the way that phone number spoofing is allowed. That's interesting. Or caller ID spoofing. Cool. Tests run. Yay. Can we check any of this in? I mean, that was only the sand tests. I don't even know if the stuff outside of sand compiles. That's a nope. Oh, did I not try building the sand binary, just the library? Let's just do that. Duco's wandering around again. Oof. Do we still have an old protocol file or something? No more target. I said no more target. Oh! I do need to update the cargo toml. Try to fix this weird nested build now. Oh man, the COVID is especially bad here right now. I miss being able to like go to the local pizza place and get a pizza and a beer and just like hang out with whoever. Where is that actually coming from? Oh. Out/protocol. Oh. This is so weird. Okay. So the protocol module, the protocol crate is part of the outer workspace, but it's almost kind of like we've got this weird like nested workspace inside the outer crate that we're using for building the sand runtime. And it's still using a relative path there, but it's in the output directory now. So I think I just need to copy this. And I don't think I need to change its name like I was before, because this one actually is part of the outer workspace. Oh, this is so weird. I feel like builder is not extremely accurate anymore. I could use just the plain old out directory, but it feels cleaner to actually make this like sand build and then put the other crate directories inside that. And this does depend on the protocol crate now. The cargo.lock for this is kind of weird. Like, I think we'll end up having no cargo.lock in the protocol directory because it's nominally part of the outer workspace. When it's actually compiled as part of the outer workspace, it'll use the outer cargo.lock. And then when we're doing this nested build, I think it'll use the sand cargo.lock. But preparing that lock file is going to be a little weird. I think that'll be basically the same, though. I think we'll just run a regular build in the sand subdirectory and then use that stow script to copy its cargo.lock and cargo.toml to the sand dash variants. I think we'll be all right. Weaver says they don't really like object-oriented languages very much, but it's cool to see people make nice stuff in them, especially in Rust. I feel like Rust is only slightly an object-oriented language. Like, Rust as a language does not really technically have an object. It has structures, it has traits, and you can make things that kind of look like objects, like you'd expect, but I don't know if it's quite fair to describe Rust as object-oriented. Oh, my Emacs is doing the build before this has actually got to it. Oh, the spinner is behind my head. Yeah. Cargo check. I was on the fence about whether to give these directories separate names. Does this really... I guess this takes a reference or an owned copy. Is that still long enough? It doesn't fit on one line. Yeah, it's fine. Let's just do a fresh build here. Oh, come on. Oh, Zimzil says they're looking forward to async Rust in embedded, no standard, no alloc, no RTOS. I mean, that's basically what this is doing. I mean, it runs on Linux, but Linux isn't an RTOS. Yeah, I mean, I'm doing that in the sandbox process here. You could probably do that on a microcontroller in pretty much the same way. I mean, this code basically ends up creating an extremely simple async runtime that just does what I need it to do. So like process, task. So like this is async Rust running in like really low level, no standard user space code. That is the actual entry point, this task function. Where's our future that actually runs this? I think that's the process module here. Yeah, so process is sort of a container for a task in its current state and queues that you can send events in and out of it with. Yeah, there's the basically trivial waker implementation, since we're not really using wakers, but they're a required part of the future. Oh, okay, yeah, so I guess this is why Zimzel was interested. That's cool. And then Weeber Lover says there is a project for making an OS with Rust. There are several OSs people are writing with Rust. Yeah, I haven't looked at them close enough to really comment, but there's like something Google is writing to eat the world, and there are several toy OSs, and I don't know if there's anything in between. Well, this build is taking long enough that maybe it's working, but it's kind of concerning how long it's taking, actually. Is it trying to build the entire outer workspace? Oh, actually, let's do this with -VV. Well, I don't think it'll care about the third verbose flag, but 2 verbose flags will give us the build script output at least. Yeah, it seems everybody does an OS. Basically, I mean, writing an OS is a great way to understand how computers work, so it's a pretty good project for any sort of coming-of-age nerd who wants to understand how computers work in more detail. Oh, I don't know if this is working. It shouldn't be taking this long to build. I guess it still is in the build script. Don't see any target directory in either of these. Let's just make a copy of this and try compiling it separately. So this is just the Rust files and the cargo files. Kind of seems like this wasn't making any progress at all. That's huge. That's better. 169K stripped. That's much better. it doing that automatically on a release build? I've got this configured so the debug builds and release builds are very similar. But I think it still might not be stripping the debug build and might be stripping the release build. Yeah, that's better. Okay. I guess I could probably still strip that more, huh? Yes. Could I do that in my build without depending on an extra tool chain? Right? Like, it would be nice to run strip there, but currently this nested build only depends on cargo. Let's do a quick search. I'm guessing the current defaults we have strip the debug info, but not the symbols. It's weird that it says either symbols or debug info, because it seems like stripping the symbols would also imply that you're stripping the debug info. But the way this is written is kind of weird. Yeah. That's what I want. Mostly the reason to strip symbols here is that they really are not useful. Like, there's no practical way to debug this using debug symbols right now, so it's purely wasted space. Gosh, is it just me, or do people have less interest in making an OS these days? Maybe it was just the particular, like, kind of nerdy forces that caused, like, I don't know, I'm kind of overusing the word nerdy because it feels nostalgic to me, but, like, I guess what I really mean is that, you know, when I grew up with computering, it was a thing that you did because it was complicated and esoteric, not because it was useful for a particular purpose. And so people who got into computering to explore all the weird complexities of how it works, I think maybe are more likely to want to build an operating system than like the average person who uses a computer these days. there are lots of interesting resources now for making an OS. Like, it used to be you kind of just had to like disassemble stuff and figure it out yourself, or find the right expensive book. And now there's just lots of stuff on the internet. Like, even when I was a bit younger and I was like kind of making some stuff for the first time or the second time, it was nice to have the OS Dev wiki and stuff like that, or be able to just like search the internet for specs that you need. There's still a bunch of specs that are annoyingly hard to find because they're like legally encumbered in some way. But luckily, at least, even for the specs that you can't get direct access to, often somebody has published like open source code or some kind of description that is at least close enough, and you can use that as a reference. What is going on with this build? This has got to be a workspace problem. Like, I bet in the nested build, this was probably working before because I copied it to a separate directory, but when it normally runs, that's probably running from inside. Yeah, it's probably running from inside the target directory, and so cargo just looks up until it finds another cargo.toml that has a workspace in it. So I don't know if I can actually include the protocol in my outer workspace either. Whoops. Right now my workspace, I had just the CLI in there. I was hoping to include protocol. Like, I could make a different version of... See, like, the problem is not this. The problem is that when cargo is actually evaluating the cargo.toml for the protocol crate, it doesn't know it doesn't know whether that crate's in a workspace or not. So then it searches to see if it can find a workspace. Whereas with the sand subcrate, I had to explicitly say this is not part of the workspace, and so that's fine. It doesn't try to look for the rest of the project and compile it. But I think in this case I've got behavior that depends on what directory I'm in. So let's try just taking it out entirely. I think this will still build. I don't totally know what the implications are going to be in terms of how annoying that's going to be to not have that in the workspace. It does seem that's because it's following this link now. Maybe I need to make... I don't know, like I could make another, I don't know, like basically a fake cargo.toml for the workspace when I'm building the sand project. I don't think I can do that. Do I just want to copy the protocol as a subdirectory of this project? That might be less weird. Right, let's leave this as the default. So now when this is building the outer project, this will appear to be part of the outer workspace like Cargo expects. And when we're building the inner project, it seems to be part of its workspace. Maybe. I guess I do need to define protocol as a member in that workspace explicitly. Oh. Oh, this is the unstable dock. Did not realize that. That's fine. I mean, I've been using nightly features in the sand, but not in the outside process. Okay. Does that just go outside of all the sections? All right. Let me start an actually fresh build, and then I've got to take a brief coffee/bathroom trip, and I'll be right back. Tuco's still Tuco's still sleeping in his usual place on the other side of the house. Do we have a build? Looks like it might be a build. Do we have tests? Brr. Gosh, I'm kind of used to being about 6 foot that way and under a blanket. It's a little colder on this side of the room. LibLTO. Cool. This is a little bit weird, but at least working on the inside of the protocol should be nicer now. Tests. Oh, some tests. Okay, that's about what I expected. So a lot of the tests are, I mean, this is better than I expected. Like, a lot of the tests are working. This one that's failing is where we're trying to run the nested build and run its tests. So that definitely needs some adjustment. Oh, is this going to want to have a copy of protocol? Do I make this even worse and use some symbolic links for the unit tests? I mean, it seems like I could. So, I mean, I could do something just like build RS and assemble this in a separate directory into the build, but I actually do kind of like how running the unit tests actually does it in place. That makes development a little bit easier. So far, so good. I should set up a camera on Tuco's other hangout on the other side of the house. Yeah, let's add that to the git ignore. I guess git considers that a file. Yeah, okay. right? Like all of these are actually only used for the kind of development mode or test mode builds here, where we're making local in-place copies of the cargo, etc., and having a local target directory. Oops. I didn't want to close that. Oh, that's actually a good thing to discover, though. Platypus says, no OS, only beep, and you're in the basic prompt. That was reminding me of thinking about doing all this address space layout stuff for loading processes and how everything's randomized. All the segments are randomized separately, like your stack's randomized, your nmaps are randomized, your base address is randomized. But like back when computers did just boot into BASIC, it was pretty common for all the addresses to be well known in advance. So much so that you could find books published with like, this is the address in the BASIC interpreter that does blah, or this is the address in the DOS ROM that does this. I guess the price that we paid for that was that software changed very slowly, but sometimes that was nice. Is that all the tests? I think we're back up to all the tests running after that messy refactor. Okay, so one of those trees that I cleaned up on this stream was for the stack alignment, and this other tree, which it looks like I've just cleaned up, was for splitting the protocol into a separate crate. guess I should actually wrap that a little narrower, but I don't think anybody cares. Okay, let's hop over to the other source tree, make sure that's all up to date, and then I think the next thing to do is, now that protocol is actually split out, I can actually split that file into smaller pieces, which will help me clean it up a bit. This would also maybe be kind of a nice crate to have separate documentation for. Right, I think that works now. We should be able to cargo dock the protocol crate. So there are a couple of really obvious submodules here because they're already modules just shoved into the same file. There's ABI, buffer, ser and d for the serialization and deserialization, and tests. And these are all just straightforward to split out into separate modules. And then there's this global scope here, which I think most of this I either want in a types or messages module or something along those lines. But I wanted to run cargo doc before making that change, but I guess we're waiting on cargo check or something. That's fine. It's possible that editing this protocol file is always going to be kind of, well, I don't know. I guess stuff like cargo check is going to assume that this is in the outer workspace because it is, at least until I copy it or link it. Okay, that did actually succeed. Yeah, this needs some more docs maybe, but again, this is intended to be pretty internal. This file has been in need of splitting up for a long time. It's definitely the biggest in the project. Oh, have I been using tests singular or tests plural? Mostly I've been using tests, it looks like. Looks like that's what Rust prefers anyway. This is a somewhat weird queue structure. Yeah. I like how, I really like Rust's module system. Like, it feels like it has a lot of the features that I enjoyed from writing Python, but it feels more powerful than that even, and it just feels nice to have like a language that's suitable for writing compiled code where, you're doing as much work ahead of time as possible, yet it still has a nice module system. It just feels warm and cozy to me. Tests. I feel like I want that to be in the lib file. It's Friday night drag racing outside. Where does init args go? I feel like the main distinction here is that types are little building blocks that we use in multiple places, whereas messages are the big chunky things that we send back and forth, like these big enums. But it is kind of a fuzzy distinction, which is why it's not part of the external API. This is not a basic type, this is a message. Oh, hey, Tuco. Welcome back. You're so sweet. Oh. Oh, what a cat. Tuco, don't. Tuco. Oh, there he is. Is he in a bitey mood now? Alright, Tuke, see you soon. Does he want food? Does he want to hang out? Probably both. Ah, this is gonna be so many objects. Maybe I want use crate type star here. I don't usually like to use star imports, but this seems like maybe a good place for it. Oh, hey, Tuco. Tuco. Oh, no. No. Tuco. Hey. Hey. Quit it. Tuco. Do you want actual food, little guy? Yeah, I can do that. Do you want more of this? Oh, little guy. Hmm. And too bad you don't get smell-o-vision. This is always extremely meaty flavored. Okay, docks build. Now he's leaving again. This is what I get for having documentation for a module that doesn't even really need it, is now I want to fill in the doc comments. This is getting really slow, like it's running the very parallelized part of the build. I should probably have an activity monitor for this machine up on the screen or something. So right now I think this computer is totally I/O bottlenecked, like the desktop menu is not opening. To go. Hey, Tuco's back. Oh, the unit tests are running. Yay. I might be able to check in some more cleanup. Looks like the continuous integration is still passing. Cat stream. Yay. All three of those Ubuntu tests pass. Cool. Yay, so many files. Brr. This is probably the best stopping point I'm gonna get for a little while. Might be a good time to make some food and hang out with my cat. Oh, Tuco. Hey, Tuco. Tuke. Ah. You found a wire that I haven't protected. It's a USB camera. Oh, Tuke. There's so much green light spill in this room when I have the green screen on. Hey, Tuco. Hey. Tuco. You're gonna make me cover that right now. This tripod is not really optimal for video. Well, yes, we got some cleanup done. We got some more tests passing. It's all cool. Cool and good. Too cool. Tuco, what are you chewing on now? Oh gosh, I moved around some of the stuff in the studio and he's finding all of its weak points already. There's a network cable that I haven't protected and a USB cable that I haven't protected, and he's chewing on both of those already. Oh gosh. Like, neither one is that hazardous or expensive, but it's still frustrating. All right. Well, I think the unit tests are still passing, and I think we're at a good stopping point, so maybe I will wind this down for today. Just for a little more context, this has been a work in progress sandbox thing that I've been building in Rust. You can find the code here on GitHub if you want. I'm doing this mainly so that I have a good environment for doing transcodes in from this video server project that I'm also trying to build in Rust. But this is the piece that I've been working on recently. Oh, Tuco, don't chew headphones. Oh my gosh. Yeah, this little guy wants attention after sleeping through basically the whole stream. But yeah, thanks for joining me on this little development adventure, and a special thanks to everyone who supports me on Patreon. That's really what helps me do this as much as I do. And if you want to give me some feedback on like what things you want to see more of or what things you see less of, that's always appreciated. And if you want to chip in a couple bucks a month to help this keep going, that's always super appreciated at patreon.com/scanlime. And if you just want to keep up with the latest streams, I've got a bot at twitter.com/scanlimelive that announces the streams. You can also follow on Twitch, twitch.tv/scanlime or scanlimelive. Those links have also been scrolling up there the entire time. So let's hang out here as long as Tuco is comfortable, which will probably be like 3 seconds. What? That sounded vaguely dissatisfied, but he's not actually getting up. Now you want up? Okay. All right. I'll see you all next time. Happy hacking, everyone.